All right, my friends, let's see if I can make it through this whole thing without coughing. Section 9.3 is about hyperbolas. And just for a quick warm-up, I'd like for you to graph the equation x squared over 9 plus y squared over 16 equals 1. So remember that at any time, if you'd like to pause the videos just to make sure you can do something before I go through it, that would probably be a best practice. Okay, with that said, you can see that x is squared and y is being squared, which is what says I am not a parabola or just a line graph. And you can see no evidence inside the square functions of shifting either horizontally or vertically. You can see that underneath x squared is 3 squared. So from the center in the x direction, we would go out 3 units to get to what will be the covertices in this case. And then from the center, which is at 0, 0, underneath y squared you see 16, so that means that you'd go up 4 and down 4. Okay, from here, an optional boundary box for anybody that struggles with drawing nice ellipses. This boundary box can be helpful. We'll see soon that the boundary box will be required at some point. Okay. Wow, that looks bad. Oh, missed it by that much. There we go. Okay. All right, my friends, so then let's fill in the ellipse. Remember, especially considering that ellipses represent things like planetary orbits and things like that, you want to make sure that you don't have any sharp corners. Do your best. I'm doing my best here. And the idea of turning the paper really can make it a little easier. Okay. There we go. Okay. So notice that this ellipse looks almost like a circle, which means that it would have a pretty low eccentricity value. Okay, I'm going to bring these unnecessary axes in a little bit. Okay, moving on to part B. I think what I'll do with this lesson is just in the warm-up, make sure everybody can see how easy it's going to be to graph hyperbolas, and then we'll get into the grungy business of telling the story about where the equation came from. So if you were to be given this equation here, almost exactly, except instead of a plus sign, a minus sign, then I hope it makes sense that you would not have an ellipse anymore. You would have something else. The plus sign is evidence that you were graphing a collection of points that were all such that the sum of the distance between that point and two foci would be the same constant value. The subtraction sign here means that is evidence of you graphing a collection of points such that the difference of the distances between those points and two fixed points is always the same fixed value. So, so instead of an ellipse, you'll end up with a hyperbola. So to graph it, I think I'll try to stick with the tick marks that are a little closer together this time. Can I do it? So to graph it, you'd actually do almost exactly the same thing that you did over here. It's just now the boundary box becomes necessary. So centered at 0, 0. From your center, you'll go out 3 in the x direction. You'll go out 4 in the y direction. With a hyperbola, you do need to draw the boundary box. And then you just draw what will become the asymptotes of the function. Now the asymptotes should always hit, each asymptote should hit 3 important points. The center of your hyperbola, which in this case is 0, 0, the corner of your boundary box, and then the opposite corner of your boundary box. There we go. Okay. To finish it out, you're just going to show where the actual hyperbola would go. Since your x term is positive and your y term is negative, you let the positive term indicate the direction that your hyperbola will open. So since the x term is positive, your hyperbola will open in the x direction. So this point right here that's on your boundary box becomes the vertex of your hyperbola. And then your hyperbola approaches these asymptotes that you drew. There we go. So it's going to be that simple. If I give you, for part C, y squared over 16 minus x squared over 3, oops, not 3, 3 squared, I meant 9, equals 1, then not a lot would change. So still centered at 0, 0, still a hyperbola. You're still going to go in the vertical direction 4 units, since you see 4 squared here. You're still going to go in the x direction from the center 3 units, since you see 3 squared here. You're still going to draw a boundary box. And you're still going to draw those asymptotes. Asymptotes still always go through center and then the corners of your boundary box. So it's just a diagonal of this rectangle. Same thing here. Notice that the boundary box and the asymptotes are dashed because they are not actually part of your graph. They are just graphing aids. They're just structure. Now, the only difference between this graph and this one up here is here, since your y term is positive, it would make your parabola open in the y direction. So in this case, this point 0, 4 would become a vertex. And then the point 0, negative 4 would be the other vertex. There we go. Okay. Also, just briefly, you will have a Pythagorean identity for ellipses. Here, worth noting, the letter C is still the distance between the center and the focus. Okay. The foci are always going to be located on what's called the transverse axis. So for part B, that would be the x-axis, and for part C, the transverse axis would be the y-axis. Your foci will always be located where your hyperbola is opening toward it. So in this case, I'll show you, but you're going to end up with foci for this at one at 5, 0, and one at negative 5, 0. And then for this example, you'd end up, again, your foci will always be on the transverse axis. Oops. Because your graph will always open toward the foci, okay? So the Pythagorean identity for ellipses, for ellipses, it looks like the Pythagorean theorem is as it should be. Okay, so just a little bit of a crash course here. So for this problem right here, if you were asked to find the foci, you would simply say, okay, well, I know that c squared is equal to, and it doesn't really matter for this one which one you put in for a and b. There's no issue with getting imaginaries or anything. So you could just say it's equal to 9 plus 16. So c squared then would equal 25, which means your c value would be, you could say plus or minus 5, I guess. So I guess I should say the absolute value of c is the distance between the center and the focus. So that would lead you to know then that this point right here, 5, 0 would be one of the foci, and negative 5, 0 would be the other. If you're asked to find the foci of this picture right here, the work would be very repetitive with what we just did for part B, and you'd end up finding that you'd have one focus at 0, 5, and the other focus at 0, negative 5. All right, my friends, we're going to leave this here for part 1, and then we'll do another part for the derivation and the grungy stuff, and then a couple more examples. Hope you're doing great.